This is geometry, section 9.2, reflections in the plane. So what we mean by in the plane is we're only going to be talking about reflections on a flat surface. So across a flat surface, which we know is a plane. So this picture right here shows an example of a reflection. It says the picture at the left portrays a transformation. What would you say happened to triangle SAW to make it turn into triangle PER? Well, if we look at it, this is kind of symmetric. So S is in the same position as P, A is in the same position as E, W is in the same position as R. Everything is just flipped across the x-axis. Okay, so the x-axis is right in the middle of these two shapes. It's flipped across the x-axis, or we say that it's reflected across the x-axis. That would be the technical term for it that we would use. How are the corresponding points of both triangles related? So if we look at these corresponding points, so like we said, A corresponds with E, well, the x-coordinate of both of them is the same. The x-coordinate is right here, 9. And the y-coordinate, well, this is a +2, this is a -2. So the x-coordinates, that's going to happen for all of these. If we compare the coordinates of all of these points, the x-coordinates stay the same. The y-coordinates are the opposite of what they were before. So if I reflect something over the x-axis, all the x-coordinates stay the same. The y-coordinates are going to flip, or they're going to change signs. So a reflection, formal definition, a reflection in line M, or this really means over line M. So if we draw a line right here, and we call it M, this is called our line of reflection. So this is something, the line that we're reflecting something over. So we'll just do points for now. We'll call this point P. So it's a transformation that maps every point P to a point P prime, just like we did with translations. We use that little tick mark. We call it prime just to relate one point to the other to say, okay, P turns into P prime. So P prime would be here if I reflect this over that line M, such that the following properties are true. So if this is a reflection, then if P is not on M, if it's not on the line, which it's not here, then the distance between these 2 points and the line is going to be the same. So we can say P and P prime are equidistant. We learned that word a long time ago. It means the same distance away, are equidistant to line M. If P is on the line, it's on M, then if I try to reflect it over the line, it just doesn't go anywhere. So P prime would be in the exact same spot. So P would equal or be in the same place as P prime. Okay, so reflections in the coordinate plane on the xy axis. So across the x-axis, we already did this one, sort of, the example up the top. So if I call these coordinates A and B and I flip it over the x-axis, the x-coordinate stays the same. It's still in the same spot along the x-axis, so that stays A, but the B is going to change signs. It's going to turn into -B. So we're going to change the sign of y. For the y-axis, it's going to be the opposite. So if I start with this point A, comma B, and I flip it over the y-axis, so it flips this way, this one flipped this way. So if it flips this way, now the y-coordinates stay the same. So that's still B, but the a-coordinate, or the x-coordinate, if this was A, now it turns into -A. So now we're going to change the sign of the x-coordinate. And if I reflect over the line y equals x, the line y equals x is just a diagonal line that goes straight through. The slope is 1, so it just goes right diagonally across the coordinate plane. This one's a little bit trickier. So if I have a point, we'll put it right here. We'll say this is A and this is B. So the coordinates would be A, comma B. If I flip it over this axis, now these coordinates are actually going to flip. So now this y-coordinate is going to be the same as the x-coordinate was before, and the x-coordinate is going to be the same as the y-coordinate was before. So now this is going to turn into B, comma A. So the x and y are going to switch for that one. Okay, so the image of A, comma B for each of these, so if our pre-image is AB, the image after we reflect it, if we reflect it over the x-axis, it turned into A, comma -B. Over the y-axis, it turned into -A, comma B. Over y equals x, it turned into B, comma A. Okay, so an example, if we take the point 3, 2 and reflect it over the x-axis, x stays the same, y becomes negative. If we take the point 4, 7 and reflect it over the y-axis, x turns negative, y stays the same. If we take the point 1, 6 and reflect it over y equals x, x and y just switch, so it becomes 6, 1. Okay, use the diagram at the right to complete the following. Also graph each of these. So if triangle FAN, which we have right here, turns into triangle GBS, and that's a reflection over the x-axis. So we're going to take all of these points and reflect them over the x-axis. So to do that, we know it's going to be equidistant, the image and the pre-image, from the line of reflection. So if the x-axis is our line of reflection, we want to count how far each of these points are from that line. So A is 1, 2, 3 spots away, so I'm going to go 3 spots in the other direction, and that's going to be A turns into B, it says. So this is going to be B. F is also 3 spots away, so I go 3 spots the other way. F turns into G, so I'm going to call that G. And N is 1, 2, 3, 4, 5, 6 spots away, or we can also think about it as it's 1, 2, 3 spots away from A. So we're going to go 3 spots further than B already was, and that's going to turn into, N turns into S. Okay. So when we reflect it over the x-axis, those are our points. As we know, the rule is all the x's stay the same, the y's just change signs. So F turns into, like we said, G, A turns into B, N turns into S, and G would be 7, -3. This would be 2, -3, and this would be 2, -6. Okay, same thing for the y. So F is going to turn into T, A is going to turn into O, N is going to turn into M. And if we reflect over the y-axis, now the x switches, so this becomes -7, the +3 stays, -2, +3 stays, and -2, +6 stays. So if we reflect over the y-axis, now we count the distance from the y-axis. So N is 2 units apart, so is A. So we go 2 units the other way, 2 units the other way. N turned into M and A turned into O, so this is M and O. And then F is all the way over here. It's 7 units away from the x-axis, so I go 7 units the opposite direction, and F turns into T. All right, reflect the points across the line. So now we're reflecting across a different line. The line y equals 6, first of all, we need to figure out what kind of line that is. Y equals is going to cross the y-axis, remember that. So it's going to be the opposite of what the y-axis is. The y-axis is vertical, y equals is going to be a horizontal line at 6. So it's going to be right here. Okay, so it says reflect the points across the line, and then we need to write out the coordinates. So same thing we did with the other picture, we just need to count how far away it is from that line and then go the opposite way that amount. So D is 1, 2, 3 units away, so D prime would be 3 units the other way. So if we figure out the coordinates of that, it would be 2 and 3. So D is at 2, 3. E is 1, 2, 3, 4 units away, so I just go 4 units the opposite direction. So this would be E prime. This is D prime. I forgot the prime there. So E prime is at 7 and 10. W, notice W is on the line. So we wrote down for the definition of a reflection, if there's a point on the line and we try to reflect it, it just stays on the line. So W prime is still just in the same spot, 10, 6. Okay, reflect the points across the line, y equals 5. So now y equals 5 is this line right here. So if I reflect across that line, W would reflect just one spot. So W prime would be at 10, 4. E is 1, 2, 3 spots away. So I go 1, 2, 3 spots the other way. And that's at 7, 8. And D is 1, 2, 3, 4 spots away. So I go 1, 2, 3, 4 spots the other way. D prime is at 2, 1. All right, and this is extra credit. If you want to do it on your paper and turn it in, you can get extra credit in class for that.